are the papers that I would recommend. Okay, so the presentation outline, a brief introduction, and then some of the examples that I'm familiar with in Southeast Asia, a few comments and diagrams about models and the exploration implications, and some conclusions. I expect that this will probably run for about 40 to 45 minutes, and so hopefully there'll be plenty of time for questions. Firstly, the model. This is a cartoon that was published by Dick Sillitoe and Hal Bonham quite a long time ago, and it essentially shows an intrusion-related system with outboard polymetallic deposits and most distally gold sediment-hosted deposits. This model has been refined somewhat several times by Sillitoe and others, but this is the fundamental model and 3D conceptual version or vision for sediment-hosted gold deposits related to intrusive centres. And this was based on the Bingham Canyon district, where the Malco and Barney's Canyon sediment-hosted gold deposits were distal to the Bingham Copper Porphyry Canyon. On the left is a photo of Malco when it was being mined, and there's a shot of the actual jasperoid discovery outcrop at Barney's Canyon. If we take a look at this from the air, Malco and Barney's Canyon are about 7 kilometres north of the Bingham Canyon, the giant Bingham Canyon porphyry copper deposit, so that you can see we have a close spatial association between a giant porphyry copper deposit and distant sediment-hosted gold deposits. If we now look at examples from Southeast Asia, and these are the ones, or some of the ones that I'm familiar with, they have quite a wide distribution. I haven't included mainland China, but these are the examples that I'm aware of in Southeast Asia, and some of these I'm going to highlight in this presentation. One thing that becomes pretty obvious when you look at this is it seems like most of them are associated with island arcs. Here's a few numbers about the resources of these deposits. It's interesting to note that most of them are less than 5 million ounces. And so whilst they can be reasonably good grade, rarely do they have a really high endowment of gold. Typically somewhere between 500,000 and 3 million ounces would be normal. They're distributed in several countries. The most significant ones appear to be in Indonesia and Laos, Malaysia, and then there's lesser examples in the Philippines and Myanmar. Here are the characteristics of the sediment-hosted gold deposits in Southeast Asia. As I mentioned earlier, they seem to occur in island arc terrains and extensional rifts. They're often associated with porphyries. They're hosted in calcareous carbonate sediments. They have a very distinctive geochemical signature, very low gold to silver ratios, and a common presence of jasperoids. The gold is almost invariably fine-grained, associated with pyrite, Arsenian pyrite, and it's refractory, and they have a variable 3D geometry. So if we first look at the Sepon deposit, which is situated in southern Laos, this is an aerial view of the Sepon district. In the front of the slide, we can see the camp and plant facilities. Outlined in red are the gold deposits, and there are also several significant copper deposits shown in green in the Tamkam area. While we're looking at this slide, there is a close spatial distribution between the gold and copper, and the high ground in the upper center, Tamkam Hill, is actually an intrusive center. The discovery history of the Sepon district covers quite a span of time. It was first discovered by Rio Tinto in '92. and then who sold it to Oxiana, who then went into gold production and subsequently copper production over a period of 10 to 15 years. And then it was later sold to a Chinese company, Langzan Minerals. One of the difficulties in the exploration of the Sepon district was that the district sits right on one of the main venues for the Ho Chi Minh Trail. And so this was just full of unexploded ordnance. And one of the exploration challenges in exploring this region was to the necessity to have ordnance teams providing safe ways for geological mapping. Over a period of time and millions of dollars, most of the ordnance was safely extracted. And so this was then made the way for full-time exploration and ultimately development. But this was one of our major challenges, and it was a very costly exercise. Fortunately, I believe it was very successfully done, and there were no fatalities. Here's a view of, on the left side, the Nalu sediment hosted gold mineralization, and behind that is the Kanong oxide copper mineralization. If we look at a geologic plan, this scale is approximately 25 kilometers from east to west. The pink crosses represent intrusions. The green areas are copper mineralization, and generally outboard of those, we have the red areas, which represent the sediment-hosted gold mineralization. So in section, this is a section of the Nalu deposit. The black represents the jasperoid, and then the green is the decalcified shale, which occurs at the contact of the undifferentiated calcareous shales and dolomites. So very strong geochemical and stratigraphic control. This is what some of the mineralization looked like. This is in the Nalu pit, and this is part of the ore body. And what we can see here are variable zones of jasperoid silicification and carbonaceous shales. Another example from MMG's website and work done by James Cannell, who did his PhD on this area. Some nice examples of jasperoids on the left and decalcified carbonaceous shales on the right. James also did laser ablation studies on the pyrites and looked at the distribution of elements and found that there was some associated base metals, sulfur salts, and that most of the gold, in fact, all of the gold, was distributed on rims of pyrite and with almost nothing in the cores. So the gold distribution is strongly associated with the pyrite rims. We can see there on in this slide, in this section here, we've got 73 ppm gold and 88 sitting right on the edge of a pyrite rim, and the cores actually have nothing whatsoever. This too shows the same thing, perhaps in a little bit more detail, and the close association of gold on the pyrite rims. If we look at a section of the deposits, there's a strong structural control as well as stratigraphic, and the red areas are the disseminated gold mineralization and the green areas are the copper. We can clearly see here, and especially the case around Tamkum, where the copper is adjacent to the intrusion and then the gold mineralization sits outboard of that. And there's also a distribution of the various elements with respect to distance away from the intrusion. This is a relatively recent shot, and it shows the copper leach pads. Oxiana produced gold for approximately 10 years and then was transitioned into a heap leach copper operation, and now they're going back into, the Chinese group is going back into gold production, some of which will probably be underground. Now, this has been a highly, highly profitable mine over at least now 20 years. One of the interesting things about Sapon is it's quite well known for really high-end secondary copper minerals. And being a mineral collector or former mineral collector myself, I can appreciate the value of some of these minerals. Two beautiful samples of malachite and azurite, and in the bottom left, we have almost gem quality cuprite. At the time of my visit, the company was looking at setting up a cottage industry for the local community to actually extract and market these minerals. This can be a very lucrative and also productive thing for community development. There are several mines around the world that actually do this, and it can be a great source of income for the local community. If we now move to Bau, which is located in the Malaysian province of Sarawak, this has a lot of different styles of mineralization, including sediment-hosted gold, and it has a very long history. Approximately 200 years ago, Chinese entrepreneurs moved into the Bau Gold District, and in particular, one Lu Shanbang set up well-organized kongshis or work parties to extract gold way back in 1820. So Bau has more than 200 years of history of gold production. It was later in the 1890s when a British company moved in, and this was called the British Borneo Gold Mining Company. And the peak production was around 1920 from the Tai Parrot mine, and this produced just over 1 million ounces. And a geologic map of the Bau district, as I mentioned, there are a number of deposits. Collectively, most likely there is at least 3 million ounces endowment in this district, and this would be over, the deposits are distributed over a strike length of approximately 20 kilometers in a northeast trending structural corridor. This is a photo I took at the Tai Parrot mine when it was last in production around the 1990s. It was mined by open pit methods, and it ceased production, I think, around 2000, more or less. The Tai Parrot was the main center for gold mining in the Bau district, and it was essentially jasperoids, which are shown in black, that had developed in near a contact of shales and Bau limestone. This limestone had a karst development, and so much of the early material that was actually mined, which is shown, the mining shown here in the white outline, was actually intrakarst material. And when that was mined, they started to develop the actual mineralization in the limestones. And that's shown here in this cross section, where we have the contact of the shales and the limestones, and the brecciated and silicified sediments, which were essentially intrakarstic, and then that led down into the primary mineralization at the limestone contact. Here's what some of the rocks look like from around the main area of mining, the Tai Parrot. And we can see here some quite good grades, actually, in silicified and decalcified carbonaceous shales and limestones. There is also associated realgar and orpiment, and in some cases, stibnite. The main area of interest at the moment is actually a few kilometers away from the Tai Parrot, and it's at a place called Jugan Hill. And the mineralization at Jugan is entirely hosted in carbonaceous shales. Here is some drill core photos of the highly mineralized carbonaceous shales. And the mineralization here is actually associated with extremely fine acicular disseminated needles of arsenopyrite. Quite difficult to see with the naked eye. However, with the hand lens, it's very obvious the acicular habit of the arsenopyrite. And there is later also a cross-cutting anchorite and calcite veining, which is late stage alteration. This is from the Besra website. Besra is a company that's currently working at Bao, and it shows an earlier version of the block model. And so far, they've estimated that there's almost 18 million tonnes at 1.5 grams gold for roughly 870,000 ounces. However, whilst it's outcropping at surface and potentially open pittable, one of the challenges is the refractory nature of the gold. And here is another table from Besra's website, and it shows their estimated resources for several projects in the Bao district. The main one you can see there is Jugan Hill. Periju and Saisang are also sediment-hosted gold deposits. Seruyung is intrusion related, and Bekajang and Taiton are more vein-style deposits. So some laser ablation work that was done by Go in 2012, he also showed that the gold mineralization is clearly focused around the rims of the arsenopyrite. There's skarn mineralization present at Bao, and here are some cut slabs of that style of mineralization. Also quite nice gold in places, up to several ounces in some of the skarns. They're relatively small, but not well explored, and so there is potential for significant skarn-hosted gold mineralization at Bao. And here's some of the intrusion-related mineralization, where we can see altered porphyritic intrusions with disseminated gold associated with pyrite and arsenopyrite. And so in addition to that, there's porphyry-style mineralization that's been recognized. And so the porphyry potential at Bao is relatively unexplored and may be quite good. The next deposit we'll look at is in Sulawesi on the northern arm of the island of Sulawesi. Is called Messel. This is a classic sediment-hosted gold deposit, and it was discovered and mined by Newmont. The discovery history relates back to early exploration by Newmont in the area, and they first recognized epithermal vein-style mineralization in a karstic terrain, not unlike the Taiparot actually in Bao. And then a little while later, they came across the sediment-hosted gold mineralization, firstly as float, and then with geochemistry, they traced it back to its source. This was a photo taken in the early development of the Messel deposit, and it's the upper part of the Hines ore body. It's quite oxidized, and there's a recent volcanic cover, which made exploration somewhat difficult and challenging. But once they opened it up, they clearly saw all the sediment-hosted carbonaceous volcanoclastic breccias that hosted the mineralization. Here's a section of the main zones of mineralization. There are structural feeders, and then the decalcification and clay pyrite alteration occurred underneath andesites, which actually acted as barriers. And so the fluids ponded underneath the andesite volcanic barriers. This is what some of the rocks look like from Messel. There was also not only arsenic and realgar orpiment, but there was some cinnabar associated with the mineralization. The bottom left is typical of the ore at Messel. It was carbonaceous and calcareous. The gold is associated with arsenopyrite, and therefore it was refractory. They had to build a roaster, a small roasting plant, which was very effective and handled in a very environmentally responsible way. And on the upper right is just an example of some of the epithermal style mineralization. There was a USGS publication by Hofstra and Christensen in 2002, and they were comparing some of the other sediment-hosted gold deposits to those that were known from the Karlan district. And the sediment-hosted gold deposits in Southeast Asia have very similar geochemical signatures to those of the Carlin Trend in Nevada, and the principal indicators being thallium, mercury, antimony, and arsenic. Similarly, they also studied sulfur isotopes and found that most of the sulfur at Messel, at least, was probably magmatic. And so this was somewhat different to those, the studies that were done from the Carlin deposits. And in summary, on the left were the main characteristics for the Nevadan deposits. The differences mainly are the tectonic setting, because all of the Carlin Trend deposits are essentially located on continental magmatic arcs, whereas the known deposits, or the deposits I'm talking about in this presentation, are associated with oceanic magmatic arcs. Extension and transpression is really important because this provides the channelway for the fluids. And the actual fluid compositions, it would seem that the Carlin deposits there's quite a mixture, including meteoric water, whereas at Messel, most of the fluid source seemed to be magmatic, and the same applied to the sulfur. And it's clear in the Southeast Asian deposits that most of them, if not all of them, are Pluton related. There is quite a controversy at the moment about the origin of the fluids in the Carlin deposits in Nevada, and ultimately the fluid sources for those may too also be magmatic. Here's a geologic map of the Messel area. It's from Steve Turner. And so the grey areas are the sediment-hosted gold deposits. The Ratatok epithermal district is shown there down in the southeast part of the map. And then the red areas are all the known intrusions. So it's really tempting to think that somehow or somewhere these intrusion-related, the intrusions here are related to both the sediment-hosted gold deposits and the epithermals. If we now look at some deposits in Sumatra, in northern Sumatra, and they're located on the Trans-Sumatran Fault Zone. The first one we looked at is Siaho. This is a photo of the Siaho exploration camp taken quite some time ago. You can see the core shed in the foreground. For those of you that haven't worked in the tropics before or may work in the future, this is typically what your exploration camp might look like. If it's in a fairly remote area, most likely it will be helicopter supported. You can see the helipad there just between the core shed and some of the accommodation. And typically you would spend perhaps 3 to 4 weeks or longer in the exploration camp conducting your field work. This just quickly shows the distribution of a few of the gold deposits in the Sumatran Fault Zone. There are many, and there are also quite a few very significant porphyry copper deposits in this Trans-Sumatran Fault Zone. This fault zone, major fault zone or crustal feature, actually extends right up through into central Myanmar. A regional geologic map of the Siaho Pongkut Gold Project area. The sediment-hosted gold deposits are shown there up in the northern part of the license, and there are a number of known porphyry copper deposits also in the same district. So once again, there's a spatial distribution, if not genetic relationship, between the porphyries and the sediment-hosted gold deposits. There are also skarns present in this district as well. So a schematic cross-section of the mineralization at Siaho. It's essentially occurs as strata-bound replacement lodes in dolomitized Permian limestones and dolomites. And the red areas here are shown are jasperoids, and this is where most of the mineralization sits. There's an interesting intrakarst fill deposit also that outcrops and could be part of a significant resource. The estimated endowment here is roughly 17 million tonnes at 2.7 gold for approximately 1.5 million ounces. This is what some of the mineralization looks like in drill core. Jasperoid breccias, dolomitized carbonaceous calcareous sediments, and the mineralization is occurring associated with very, very fine-grained pyrite, and it's refractory. A few more shots of drill core showing the jasperoid breccias, and then an overprinting barren milky quartz phase. This table shows some of the styles of mineralization, drill intercepts, and potential resources in the Sediment district. I think the thing to note here is that once again, we have epithermal, low sulfidation epithermal quartz veins, we have skarns, we have sediment-hosted mineralization, and we have porphyries. Another interesting deposit in the northern tip of Sumatra is Abong. And there's a view of the exploration camp at Abong. Access here is a little easier, and you can see that it's more of a pine forest rather than virgin jungle. And so the exploration program here would be significantly easier and relatively cheaper than what we saw at Sediment. The district geological plan, we're looking at volcanics, carbonate sediments, and some intrusions. Abong sits up here. It's close to a porphyry intrusion. This is the sediment-hosted mineralization, and there are a number of porphyry copper deposits in the southern part of the district. Some of these were discovered long before the sediment-hosted gold mineralization. I think it was Rio Tinto or CRA way back that found Isi, and then much later the Tankarang porphyries were found and the sediment-hosted gold mineralization at Abong. Looking at the scale here, from the sediment-hosted mineralization to the porphyry is approximately 7 kilometres, at least in plan. There may be a mineralized porphyry source closer and underlying Abong. That's a cross-section showing that the mineralization is occurring in a jasperoid horizon at the contact of mudstones and limestones. There's a view of the mineralized jasperoid outcrops, and as is often the case with this style of mineralization, because the mineralization occurs within or associated with jasperoids, they tend to form very prominent topographic features. So this would be something to bear in mind if you were doing an aerial reconnaissance or looking at Google Earth. You would be looking for areas of resistive highs that might represent the jasperoids. Some drill core showing some of the jasperoid development and silicified shales and carbonate rocks. Some quite good grades at Abong. And then once again, we also see that barren late stage milky to chalcedonic quartz overprint. The gold is, like all the other examples, it's extremely fine grained and associated with disseminated pyrite. Moving on to Myanmar, where there are a couple of also very interesting examples. The main one being the Khalkpato gold mine. This has been known for several decades, and it was first developed in the 70s, I believe, situated in northern Myanmar. This is an aerial view of the Khalkpato open pit. And the mineralization is essentially occurring in argillic decalcified zones associated with some quartz stockwork veining at the contact of sandstone and shales. There's some images there on the right that show what the mineralization looks like. And once again, the gold mineralization is distributed around the margins of fine-grained pyrite. Kalkbito has an estimated resource of around 6.4 million tonnes for an endowment of roughly 600,000 ounces. Further to the south of Kalkbito, there are several jasperoid gold-bearing occurrences, most of which are the subject of small-scale mining, and this is somewhat reminiscent of what we saw at Arbong, with jasperoid ledges and artisanal mining focused on those jasperoids. Some of the mineralized samples from Gegalor, we can see that there's a lot of jasperoid development, and much of which is brecciated. So this is what is carrying the gold at Gegalor. And it's, once again, if it's not oxidized, it's associated with very, very fine-grained pyrite. So obviously the artisanal miners are going for the oxide material where they can physically extract some of the gold. Moving now to the Philippines, where there are at least two fairly well-known sediment-hosted gold deposits. The main one is at Ivanhoe, which is located in Davao del Norte province in eastern Mindanao. Ivanhoe was an area that had a couple of pre-Second World War American mines, both open pit and underground. These stopped during the Second World War, and since that time, they've been subjected to continual artisanal mining, which actually carries on even to this day. The main mine at Ivanhoe was in a brecciated jasperoid zone, and it had an estimated resource of around 1.7 million tonnes at 3.4 gold. Some studies done a long time ago demonstrated that there was fine-grained gold with the pyrite, and it was associated with arsenic and antimony, and the mineralization is jasperoid breccias at the contact of calcareous, wackies, volcanoclastics, and limestones, as shown in this cartoon. So there was a structural control to the distribution of the brecciation, as well as the lithologic contact of the limestone and calcareous sediments. This area is very underexplored and has potential for significant mineralization, both around and adjacent to these known deposits. Here are some cut slabs of what that mineralization looks like. Some of the grades are quite nice. Fine-grained gold associated with disseminated pyrite and arsenic and antimony. One of the interesting things about Ivanhoe is that on the district scale, it's quite close to a major epithermal mining camp called Masara. Masara is one of the classic long-time epithermal gold mining districts of the Philippines. It's still in production today. It goes back to the Spanish times. And not only are there epithermals at Masara, which is the subject of the current mining, there are a number of almost unexplored porphyry copper deposits, one of which, the Amcam pit, was mined significantly during the Marcos era. That's shown in the southeast part of the map. However, other porphyries such as Pagasa and some of the Tarago areas, almost no exploration has been done. And I believe that there's excellent potential for gold-rich copper porphyries there. So, and the sediment-hosted gold mineralization known in the northern part of this district as well. Once again, the spatial association of epithermals. There are some skarns known here as well, and sediment-hosted gold deposits. Here are a couple of photos of the outcropping porphyry copper stockwork vein mineralization at Masara. These are from two different deposits, classic stockwork veining, and very underexplored, from Pagasa and Mapula porphyry copper deposits. These would be about 5 to 6 kilometres to the north of the Ivanhoe sediment-hosted gold mineralization. Another interesting area that's very underexplored is Las Kogan. This is in the Seruyung district in the very northeastern part of Mindanao. And there too are porphyries and sediment-hosted gold deposits and epithermals. So the main sediment-hosted gold deposit here is called Las Kogan, which is shown there with the yellow arrow. And then the known porphyries are shown with the red arrow, and these are the Suyok and Antina deposits, which are currently being explored and were previously mined by Manila Mining. The distance between the sediment-hosted mineralization and the porphyries is approximately 2 kilometers. Some outcropping, some shots of the outcrops at the Las Kogan deposit. This has had very little exploration apart from some drilling, minor drilling and trenching. However, the style of the mineralization, it's clearly sediment-hosted and occurs at the contact of carbonate rocks and volcanoclastics. The two samples on the left are from a paper that was published in Resource Geology by Maglambayan, et al. In 2005, should any of you want to find out more about this. There are other areas where there's significant jasperoid stream flow, some of which is well mineralized. This really has had almost no exploration, and it's part of the area peripheral to the known porphyry mineralization. If we move now to the porphyry mineralization, this plan shows where the gold-bearing jasperoid floats have been found, and where recent or relatively recent discoveries of significant porphyries have been found underneath known epithermal mineralization. So there's two jasperoid occurrences. There's Phylex's Las Kogan, and then there's MMC's Dulungan deposit sitting up here, and these are outbound of a major porphyry copper center. If we move now to the porphyry, this is a drill plan, a model from the drilling that was done not too long ago underneath a known epithermal system called Antina. And once deeper drilling was done below this, a very nice gold copper rich porphyry deposit was intersected. And this is currently being drill evaluated at the moment. One of the interesting things to look for if you're involved in porphyry copper exploration is to look at the gold to copper ratio, because if you see gold to copper ratios where it's greater than 1, meaning to say 1 gram gold and say 0.5 copper, then that's a very good sign for significant gold-rich copper porphyries. Clearly, from an economic perspective, these are the porphyry copper deposits that you would like to find simply because of the gold credit. This is what some of the porphyry copper gold mineralization looks like from Antina, some of the drill core photos. And as I commented earlier, look at those lovely gold to copper ratios. Now, if we look at element distribution, going from a porphyry center outbound to the distal margins, it was actually Emmons realized or recognized this nearly 100 years ago in a paper he published in Economic Geology. And it shows a simple zonation that one sees moving away from an intrusive center to the outbound distal zones. Jones, in a paper in 1992 in Economic Geology, published this diagram, which is a plan of the Bingham district, as we saw earlier, and this I'm sure was taken into consideration by Sillitoe and Bonham. So we have the Bingham porphyry copper deposit, which is the red area in the center. And then outbound of that is the Car Fork lead zinc skarns and carbonate hosted mineralization. And finally, right at the margin is the sediment hosted deposits at Melco and Barney's Canyon. And so going back to the Sillitoe and Bonham model, it shows the intrusive center, skarn going outbound into polymetallic replacement or carbonate replacement deposits. Outbound of that, structurally controlled jasperoid gold mineralization, or if we move it even further, the fluids can form distal disseminated gold deposits and jasperoids. Dick modified this model after spending time in the Philippines, and then subsequently again in a very classical, in a very seminal paper. And this was the published model in Economic Geology, which is a very good illustration of the spatial relationships of these various styles of mineralization with respect to porphyry copper centers. This is just a depiction showing drill core. So we go from our porphyry copper core out to skarn mineralization, carbonate replacement or CRD type mineralization, and finally, the most distal being the sediment hosted gold mineralization. If we take this model, it's quite easy to plug in most of the deposits that I mentioned, you can actually plug in the various styles of mineralization. So in the case of Bao, we have a known porphyry center at Gunung Ropi. We then go out into skarns and carbonate replacements at Juala and Taiton. We have the jasperoid structurally controlled mineralization at Bukit Yang. And then finally, we go out into the sediment-hosted gold deposits at Jugan and Pajero, and then also the Thai Parrot jasperoid style mineralization. So what's the significance or the potential exploration significance of this zoning pattern? There's two. One could actually, if you have a known porphyry center, then providing you have the favorable host rocks in the stratigraphy, there is potential for outbound sediment-hosted gold mineralization. And conversely, at least in an island arc environment, and there are some sediment-hosted gold deposits that are not island arc, so I'm not saying all of these are island arc related. However, in an island arc environment where you do have sediment-hosted or jasperoid-hosted gold mineralization, and you're in an island arc environment, I definitely would be thinking that there might be, within a radius of perhaps 5 to 15 kilometres, there may be some very significant porphyry copper gold mineralization. So that's something that would be in the back of my mind. So some exploration guidelines as to how you might go about this. I mentioned the possibilities of porphyries and carbon, and not only carbonate hosted mineralization, but sediment hosted gold mineralization, provided there are favorable host rocks in the stratigraphy. They tend to occur in structural corridors, perhaps tens of kilometres of scale. And in a tropical environment, the techniques of traditional mapping and sampling and stream float, you would be looking for both jasperoid float and perhaps evidence of porphyry copper mineralization. You might do a brief aerial survey in a small fixed wing aircraft, or take a good look at your Google Earth image. You would be looking for conspicuous topographic highs, which might represent resistive jasperoid bodies. And in your stream sediment geochemical surveys, I would certainly be including arsenic and antimony, and especially arsenic. And then taking into account also the district zoning that I just commented on. So if we go back now to Messel, as far as I'm aware, there hasn't been a significant porphyry copper found in the Messel district. And I may stand to be corrected here because I'm not familiar with recent exploration programs, but certainly all the smoke is there for perhaps a significant porphyry copper, copper gold deposit located in the vicinity of the Messel sediment hosted gold deposits, because there are a number of obvious intrusive plugs and stocks, and perhaps some of these may be associated with a porphyry copper system. There's been a number of papers and publications comparing making direct comparisons between some of the Southeast Asian sediment-hosted gold deposits and the North Karlan trends, I believe there's some really fundamental differences. Whilst there are certainly some similarities, but there are definitely some fundamental differences. And if we look at the main characteristics, these are the main ones considered, the boxes that you would tick for the Karlan deposits in Nevada. They have a tectonic setting which is related to continental margins and regional compression, which then undergoes post-compressional extensional tectonics, which is the actual timing of the ore deposition. They have classic geochemical signatures, such as what we see in the Southeast Asian examples. The host lithologies are very important. We also see this in the Southeast Asian examples. However, most of the mineralization in the Karlan deposits is not associated with jasperoids. Jasperoid is a product of decalcification and silicification. However, rarely is it the main ore host, unlike some of the Southeast Asian gold deposits. The alteration assemblages are quite similar. What is very different, at least thus far, is the huge difference in gold endowment. I mentioned earlier that most of the Southeast Asian sediment-hosted gold deposits are probably less than 3 million ounces. Occasionally there's one or two that might be 5, but there's yet to be a mid-tier or tier 1 deposit found in the Southeast Asian region. The photo on the left is a typical gold ore from Twin Creeks. This could be from Sapon, could be from Messel, so the rocks can actually look very similar. And to look now at what I would call, or the boxes I would tick for the sediment-hosted gold deposits in Southeast Asia, the examples I've described are in island arcs and extensional rifts. There's a clear spatial association of many of them with porphyries. The host rocks are calcareous and carbonaceous sediments of various ages. Age doesn't seem to be anything that's really definitive. There's a clear geochemical association. They have relatively low to gold-silver ratios, although not all the time. And the presence of jasperoid is almost ubiquitous, at least in some of the mineral deposits within a district. And the gold is invariably refractory, occurring with fine-grained pyrite and arsenopyrite. They have variable 3D geometry. They can be essentially strata-bound only. They can be stacked, or they can have semi-vertical feeders, or a combination thereof. And I mentioned earlier, they seem to be, globally speaking, relatively small deposits. Clearly, if these are refractory in their primary source, then the gold grades have to be significant in order to substantiate either roasting or bioleaching. So if one was to find one of these deposits, what you would like to find is one that's oxidized. And this just simply shows some of the highlights, the differences in the fluid sources and somewhat the tectonic setting. So the ones in the island arcs shown on the right, to me, very obviously have a magmatic fluid source and source of mineralization. So a few concluding remarks. I believe that the Southeast Asian sediment-hosted gold deposits are not, strictly speaking, Karlan deposits. There's a number of significant differences. I wouldn't be referring to them as Karlan-like, because I think that's quite a misleading term and shouldn't be used. They are, in most cases, intrusion-related and have some epithermal characteristics in style. And I think that actually they're best described as distal sediment-hosted epithermal deposits. And so with that, thank you very much for your kind attention, and I would be very happy to take any questions that you might have. For anyone that would like a copy of this presentation, just kindly contact Lesham. He has a copy, and I would be very happy to answer any questions now or later if you would wish to contact me. So thank you very much.
Wow, thank you very much, Mr. Kirwin, for your very interesting lecture. I think the criteria you discussed for discriminating sediment-hosted gold deposits from other deposit types, especially kaolin type, which is often used to describe sediment-hosted deposits incorrectly, is quite interesting. I mean, even though they share many similarities, there are certain key distinct features which set them apart. And I think as geologists, we need to be aware and take care of making that distinction in the future. So thank you very much for your talk, Mr. Kirwin. This is a time for questions. If any of our participants have any questions, please, you may present your questions now.
Doug, you mentioned that there's often epithermals nearby. What style are those epithermals?
In the case of, well, certainly the Philippine examples, especially Masara, they are intermediate to low sulfidation classic vein styles. That's the main example I can think of off the top of my head. Also, in some of the Sumatran examples, there are associated intermediate to low sulfidation veins. They're the main ones, I think, but definitely there's a genetic relationship with that style of epithermal mineralization and the porphyries.
And just on the metal thing, there are porphyries there, at least a couple of 100 kilometres west in the same arc. That's that thing called sure. Bulagidun that I worked on.
Yeah, the porphyry moly system. Yeah, there's a lot of porphyries in that arc. Actually, you just triggered my memory. There's classic low sulfidation epithermal veins at Ratatok too, in that Messel district. And that was what Newmont first looked at.
I think we have another question from Reza.
Okay. Hi, Doug.
Hi, Reza. Nice to meet you.
Nice to meet you. Thank you for your suggestion about the UST quartz. And yeah, I'm now investigating in the Grasberg. So I have two questions actually for you. The first one, do you think any correlation in between the preservation that may be perhaps causing lower metal endowment of, lower gold endowment in Southeast Asia sediment-hosted copper gold deposit compared to the Nevada? Maybe, is there any correlation with the preservation? Because I think, yeah, in Nevada, the sediment-hosted lies in the more tectonically stable region compared to look like in Indonesia, for example. Second one, if you got chance to conduct a drilling in the early state phase, which would you prefer, to test the smoke, the ore signature, or maybe you believe with the conceptual model to guide your drilling in the beginning phase? I think that's the question from me. Thank you.
For the first question, and they're both good questions, the levels of preservation is significant because if you were only seeing the sediment-hosted style mineralization, and perhaps Bao is a reasonably good example of that, any associated porphyry may be blind, and that would be one of the challenges at Bao because the level of erosion is such that all the sediment-hosted deposits are preserved. There's only one known small porphyry that's sticking out, outcropping at Bao that I'm aware of, and that's Gunung Ropi. But so levels of preservation, levels of erosion could be important if you're from your exploration perspective. Going back to Nevada, if we look at Bingham, and then we look at Malco and Barney's Canyon, both of those were relatively small deposits. And so there's yet to be, at least to my knowledge, a very big deposit, i.e. better than 5 million ounces, that's associated with the intrusion-related model. As you correctly stated, the tectonic and geologic setting of the Nevada and Carlin deposits is totally different to an island arc. And so, sure, one would love to find another Nevada somewhere else. And I believe you can tick a lot of the boxes for the sediment-hosted deposits in the Kyrgyz Republic, but that too has a very similar tectonic and geologic setting to Nevada. So the fundamental differences, and it's important, I believe, is the continental margin tectonic setting, and then the compressional environment, and then the later transtensional deep structure zones, which provide channelways for the fluids. The tectonic setting is really critical.
Very good. Yeah, maybe the second question is about maybe which preference will you choose for early phase drilling target, to test the smoke, or maybe following the conceptual model?
Give me the big gold rich copper porphyry any day. Yeah, that's the significance of, at least from my perspective, if I was exploring and I was finding sediment-hosted gold mineralization in an island arc environment, I would be looking for the porphyry, not really the other way around. But if I had a good porphyry and then perhaps there was another sapon or messel within 5 kilometers, that would add to the resource. But the real, from a straight economic geology perspective, the gold-rich copper porphyry would be, without a doubt, the main target.
Yeah, thank you very much. Yeah, because in the Grasberg, we have sediment-hosted gold deposit as well, but not being published yet. It's located about 1 kilometer adjacent to the Grasberg porphyry. So I think it's very possible to find elsewhere. Mm-hmm.
Okay, what's the name of that, Reza?
Wanagon Gold. Wanagon Gold. Mm-hmm.
Yeah, if there's anything published or that you could send me, I'd be very interested to look at that. Mm-hmm. It's one actually, I wasn't aware of.
One student from Jalisco University, Kelly Prendergast, she studied.
Yeah, I know she did her PhD there. Yeah, okay, all right. If you've got anything from her thesis, I'd appreciate it. Yes, thanks.
Yes, I will share. I can share to you later on.
Yeah, I know Kylie, but I'm not sure where she is at the moment.
Okay, thank you very much.
Yeah, you're welcome.
This one, associated question, short question. I would like to know the age relationship between the, for example, mineralization age of porphyry and the mineralization of this sediment-hosted gold. Is it nearly the same, or does it different?
Yeah, I think it's not a lot of work's been done on the Asian deposits, Yashushi, but I know that I think it was James Cannell who did some dating on the Zapon deposits, and yes, there was a very good correlation. I think Messel also with the epithermals and the sediment-hosted mineralization. Not a lot of work's been done to my knowledge, but I suspect that they're certainly spatially related, and I'm almost certain that they're genetically related as well. You would intuitively think that the sediment-hosted deposits are slightly younger in that they're late-stage products of the intrusive event, but all the same event overall.
Oh, thank you.
Malco and Barney's Canyon, I believe, are the same age as Bingham. That was established some time ago on dating illites, I think.
Thank you very much.
Yeah.
Okay, we have a question from Kazuki-san.
Hello, Kazuki. So I have short questions. What is the origin of the gold in SHGD deposits?
I didn't quite catch the question. I'm sorry, Kazuki. It's coming through a little blurred.
Okay. So what is the origin of gold in SHGD deposit?
Okay. Yeah. Well, it's if we accept the model, clearly it would be the intrusive porphyry systems. So they're all related, just distal products of the same thing. So the gold copper is coming from the porphyry copper. And then as you move away from that, we're more focused with lead zinc, silver style mineralization, and lower temperature and further away, we have the gold, arsenic, antimony, thallium, mercury. So it's all coming from the intrusion.
So it is not related to sedimentary hosted, like sediment included the gold plus our sorry. So thank you very much. I got it.
Okay.
Okay. Thank you.
Thank you, Kazuki. We
please
have some questions here in the chat.
Some question in the chat.
Yes, Sensei. So this is from June. What is the typical mineralization age of sediment-hosted gold deposits?
In the island arcs, typically Pliocene. There may be, I suspect there could be older examples, but as you go back in time, like with porphyry copper deposits, it's less likely that they'll be preserved. So it's the younger deposits that are preserved and the obvious ones.
Yeah, Junbon recently dated Gegalo deposit in Myanmar.
Okay.
And, yeah, the age was a 30 or 40, a little older.
Yeah. That too would fit with some of the ages, I believe, from Shangalon, which is described as a porphyry center. There's quite a few. I mean, Southeast Asia isn't the only place where these occur. Dave Royal and I studied a number of areas globally, and there's quite a few in Europe. They occur in South America. They occur in Mexico, but they all seem to have the same spatial genetic association with porphyry intrusions, especially the ones in Europe. There's some classic ones in Serbia. So they're not just confined, obviously, to Southeast Asia.
Okay, thank you. We have another question in the chats from Owi. Is the gold deposit of Phu Bia mining in Ban Huaxia? Sorry, forgive me. Yes. Can it be considered as a sediment-hosted deposit?
From what I understand, and Nick, I'd like Nick to comment on this because I've never been to Phu Bia, but from what I've read, I don't know of any replacement style mineralization in carbonate calcareous rocks or jasperoids. I believe it's epithermal, but I'll actually defer to Nick on this or anyone else that has been there to comment.
Yeah, Ban Huaxia is closer to an epithermal low sulfidation stockwork system. But the gold mineralization at Pukam, the original discovery, is really more of a distal sulfide skarn / manto. The copper is a skarn, a regular silicate magnetite skarn. The gold was distal gossans at surface after layered sediment hosted something, probably a manto style.
Thanks, Nick.
Thank you very much. I think we have one last question from Alison.
Yes, thank you, Dr. Douglas, for the very fruitful presentation. If you allow me, I am a little curious about a little information you mentioned that a gold mineralization microscopically is associated or aligned around the rims of pyrite and arsenopyrite. Does it have any explanation or interpretation for the petrogenesis?
I think it's, well, clearly chemistry is important, but also timing of the mineralization. So once the gold-bearing fluids hit an earlier pyrite, then sulfidation happens and you can precipitate the gold. As to why it's so fine-grained, I really don't have an obvious explanation for that, but it's ubiquitous that the gold is occurring associated with arsenical rims, either on pyrite or arsenopyrite. In the case of the Carlin deposits, the gold is much earlier and associated with pyrite and not arsenopyrite. Arsenopyrite is very common in some of the Southeast Asian examples, and especially Jugan. But it would really take a chemist and someone much more knowledgeable than me to properly answer your question. But it like the gold-bearing fluids, like the chemical change that happens when they hit the pyrite rims. And the pyrite is clearly pre-mineral.
Yes, Dr. Anderson, thank you very much.
Thank you. We have a question from Ronaldi.
Thank you very much for the opportunity. Mr. Kirwin, I have a question. This simple question. What are the significant conditions to have variation in the style of mineralization? Like you said, it's similar to epithermal gold vein type deposit, but why this is different style of mineralization, like a disseminated vein? So what are the important conditions to form sediment-hosted gold deposit? Thank you.
Thanks, Rinaldi. One of the, I think a fundamental condition is the composition of the host stratigraphy, because you have to have the favorable calcareous rocks for to replace the carbonates and decalcification, followed by jasperoid silicification and jasperoid development. So that's, I think, one of the key ingredients for the formation of the sediment-hosted style, as opposed to perhaps a non-reactive volcanic pile where you have a very strong, structural setting that would focus the fluids into a more conventional epithermal vein style mineralization. So fundamentally, I think it's to do with the composition of the host rocks in the stratigraphy. Because if you didn't have the favorable host rocks, then you are unable to form replacement style deposits. And if there was no sediments, well then, yeah, that's not going to work either.
Okay, thank you very much.
One more question. So jasperoid is very characteristic for this type of deposit. And is it a secondary from pyrite? The jasperoid may contain a goethite, and is it a secondary or primary?
I think it's mostly primary, Yashushi, because as the calcareous rocks, they decalcify, they get slowly but surely replaced by silica. And this actually, too, is the same process that Gene Klein has studied for the Carlin deposits. So it's essentially a primary alteration feature. And then at the time, at least in the sediment-hosted Asian deposits, I think at the time you're forming the jasperoid is also around the same time of the ore-bearing fluids. Hence, that's why the jasperoids are mineralized.
Oh, thank you very much.
Do we have any more questions from the audience?
Doug, the artisanal miners often target those jasperoids. Is that because that they contain primary coarse gold, or is that simply that the gold gets coarser as a result of the oxidation?
Yeah, I couldn't see them doing very well mining jasperoid per se, because unless they were crushing to an incredibly fine grind, they wouldn't be liberating the gold for mercury attack. So when you look at those photos, Gegalor, Hihal, I think they're really focused on the oxide material, because they can extract the gold because it's liberated due to oxidation. Yeah, there's no way they could mine the primary jasperoid and make a profit. The gold would only, through oxidation and secondary enrichment, could be become coarse enough, certainly to be economic for them. But in the case of certainly Messel, as you know, Newmont had to put in a roaster to make that work.
Okay. Perhaps that's the end of our questions. Watanabe Sensei,
this one, we have more questions in the chat.
Okay, thank you. All right, so the first question here is from Kiwo. Sorry, forgive my pronunciation. Would there be possible sediment-hosted gold style in Eastern Shan State in Myanmar, north of Tachilik at the junction of Thailand, Laos, and Myanmar?
Yeah, that's a nice question. I'm not really familiar with that district per se. I know where you mean. There is quite a lot of artisanal gold mining out there, most of which I believe is intrusion related, not porphyry. When I say intrusion related, it's disseminated in pyrite within reduced intrusions. There's a tremendous amount of illegal gold mining out there, but I'm not aware of any sediment-hosted deposits. I'm not sure even if the right stratigraphy would be present there. As you come south, there's more carbonate rocks, but I really don't know is the honest answer. But off the top of my head, I'd say probably not. It's while we're on the subject of Myanmar, Matsur, and it's nice to see you here. It's often made me wonder, where is the intrusion-related centre for Kyaukpito and Gegalor? And when you look at the regional magnetic maps of south of Kyaukpito, there is a screaming mag-high bullseye undercover. And I've often wondered, is that a porphyry copper system or an intrusion-related system? So if you were interested in the Kyaukpito Gegalor area, I would take a very good look at the aerial magnetic maps.
Any last questions? Okay, I think we won't have any questions in this session today, but as Mr. Kirwin has said, if you have any further questions in the future, please feel free to get in touch with him. Watanabe Sensei, what do you think? We can close our meeting today?
Yes, yes. Thank you very much, Doug. I have still a few questions, but
when we meet up in Denver, Yashushi.
Thank you very much. I think our students are very happy to have your lectures, and yeah, this was a very nice opportunity for us. So please keep in touch with our student chapters and chapters in Japan.
Yes, very much. I would like to do so. And if you would like any other topics or that might be of interest, either let me know or I'll find someone who can present it for you.
Okay.
Thank you very much.
Nice to meet you all. Take care. Good luck with the student chapter.
Thank you very much.
Bye.
Thank you very much.
Thank you. Nice to meet you. Thank you very much.
Thank you.